Hello students, welcome to the channel of Vedant classes. Okay, so in this lecture we'll see the image formation by concave mirror and then we'll see the image formation by convex mirror. Okay, so before starting the image formation, let's revise that what we have seen in the last lecture. If you haven't seen the last lecture, then see the lecture number 3 of the light chapter. Okay, that Vedant classes channel, you'll get that lecture number 3. Okay, so now let's revise that. In last lecture we have seen four rules. To locate an image. The first rule was, if the light rays are parallel, then it will pass through principal focus. The second rule that we have seen, if light ray pass through the principal focus, then it will be parallel to principal axis after reflection. The third rule we have seen, that if light passes through center of curvature, then it will reflect back through the center of curvature. Okay, and in the fourth one we have seen that at pole you can make a theta I equal to theta r. Okay, so at pole you can follow the laws of reflection. Generally I don't use this law, this one, because it's not always necessary that with a freehand drawing you always get the angles same. So there might be some variation in the locating the image. So in case you can use any of the two. Okay, you can use any two to locate an image. Okay, and now note one thing, that okay, when object is at infinite, when object is located at infinite, light rays will be parallel to principal axis. Okay, whenever the object will be at infinite, you need to consider the incident light rays parallel to the principal axis. Okay, so let's start with the first one. Let's say in the first case we are having the position of object at infinite. Okay, so let's consider that object is at infinite. Here somewhere very far we are having an object, right? Here we are having an object AB. Okay, very far from the mirror MN. Okay, so we need to take the incident rays parallel to the principal axis. So let's say from point A, the incident ray will be parallel to the principal axis. Then after reflection it will pass through the focus. It will pass through the focus, right? So here also you can see that at C it will make I is equal to R. Okay, this both angle will be same. From this point if you consider the incident ray, then it will be parallel to principal axis, and after reflection it will pass through principal focus like this. Okay, and if you consider from here incident ray, then it will reflect back the same path. So see, all the light rays are intersecting at this point at F. So it means that we are getting an image at F. We are getting an image at F. Okay, now see the size of image. The size of image is, you can see the height, there is no height, it is just a point like. Okay, so you can write it as highly diminished or you can write it as point wise. Okay, so the size of image will be highly diminished. Okay, you can say point like. Okay, it is just a small point like image that you can see over here. Now the rays are intersecting actually, so we will get a real and inverted image. Okay, here rays are incident actually, so we are getting an real and inverted image. Okay, now let's see the case number 2. In case number 2, we'll place an object behind the C. Okay, behind the center of curvature. So here the position of object will be behind C. Okay, so let's draw an image formation for this. Let's say we are having an object over here. We are having object A, B behind C. Okay, so first of all we need to take parallel incident ray. So this will be parallel to the principal axis. Okay, and it will pass through the focus. So in first case it will be parallel incident ray will pass through principal focus. Okay. So now you can take the second another ray. Let's say the second ray, if you want to pass it through C, you just need to extend the mirror. Otherwise you can take it from focus. Okay. So if the ray is passing through the principal focus, okay, then it will be parallel. So this will be parallel to the principal axis after reflection. Okay, this will get parallel to the principal axis after reflection. Okay, so see here rays are intersecting actually. As the rays are intersecting actually, you will get an real image. So this will be a point. Okay, so this will be B dash and this will be A dash. So this is the image that you are getting in this case. So see the position of image that you can see, the position of image is between C and F. So here position of image will be between C and F. See you are getting certain height. It is not as much as long as the object. Okay, so you can write it as diminished. So here we are getting a diminished image and the nature will be real and inverted in this case. Okay, now let's see the third case. In third case again take it objects slightly near to the mirror. Okay, so let's place the object at C. Okay, let's place the object at C. Here you are getting an object at C, that is A and B, that is our object. So again take a ray parallel to the principal axis. So here the incident right is parallel to the principal axis. Okay, now it is passing through principal focus. It will pass through principal focus like this. Okay, the second ray that you can take, passing through the principal focus. Okay, so in this case second ray is passing through principal focus. Okay, then it will reflect back. Okay, parallel to the principal axis. It will reflect back parallel to the principal axis. Okay, so you are getting an image somewhere over here. So you can see that image you are getting is at the same location. Okay, you are getting an image at the same location, that is B dash and A dash. Okay, you will always get the image in this case at C only. Okay, so if you are placing an object at C, then you will get an image at C. Okay, and the size of image that will be same size. Okay, the size of image will be same size. And again, as the two light rays are intersecting actually, you will get a real and inverted image. Okay, now let's see the fourth case. In fourth case again taking an object slightly near to the mirror. So we need to place object at between C and F. So let's say we are placing an object over here between C and F. This is our object A and B. Okay, consider the light ray parallel to the principal axis first of all. Okay, and it's not working. Okay, so this is our incident ray. Okay, now let it reflect through the principal focus. So this is our reflected ray. Okay, now we need to consider the another light ray. So we will consider the another light ray. Okay, so let's say it will pass through the focus. It will pass through the focus. You can consider any two rays, right? So this is passing through the principal focus like this. So it will reflect back. Okay, so it will reflect back parallel to the principal axis. So see, you are getting an image over here. You are getting an image slightly here behind the C. So this is B dash, this will be A dash and this will be your B dash. Okay, so see here you are getting, when you are placing an object between C and F, you will get an image beyond C. Okay. Now see, here the image is slightly larger than, so you write enlarged image. Enlarged, or you can write magnified. Okay. You can also write magnified image in this case. Here also the nature of image will be real and inverted because the rays are meeting actually at some point. Now let's see the fifth case. So in the fifth case, you need to place an object at principal focus. Okay. Now you need to consider the incident light ray parallel to the principal axis. So this light ray will be parallel to principal axis, will pass through the principal focus. Okay. So this is our incident light ray and it will pass through principal focus like this. Okay. Now if you consider the another ray passing through the C, okay, another ray passing through C like this, then it will reflect back on the same path. If it is incident like this, then it will reflect back on the same path. Okay. So you can see that these two light rays are parallel. So here the image will form at infinite. So if you placed object at F, then position of image will be at infinite. Okay. And here you will get highly enlarged image. Okay. Again it will be assumed to be meet at some point at infinite distance. So here real and inverted image will be considered. Okay. So now let's see the last case. So in last case, you can place an object between F and P. Okay. So in last case, place an object between F and P. Okay. Let's say the object is A and B. Okay. The object is A and B. If you consider the light ray that is passing through C in this case, just like the previous one. So the incident light ray will reflect back on the same path again, and you need to consider the another, let's say it is incident at point P like this, making a certain angle, let's say I. Okay. So it will reflect back like this. It will reflect back like this, making a certain angle R. Okay. So see, these two rays are diverging. Okay. These two rays are getting diverged from each other. So to obtain an image, we need to extend them back. So if you will extend them behind the mirror to get an image, okay, so it will be like this. Okay, so at this point you are getting an image. Okay, at this point A dash and B dash, you are getting an image. So in this case you will get a upright image. Okay, and as you extended the image, here you have placed an object between F and P. Okay, and position of image is behind the mirror. Here the position of image is behind the mirror. Size of image, you can see it is enlarged, and rays are extended to meet. So this image is virtual and erect. Okay, so always remember that in the sixth case you will get a virtual and image, and in all rest of the 5 cases you will get an real and inverted image. So this is the image formation by the concave mirror. Okay, now let's see the image formation by concave mirror. Okay, so let's in this you are having only 2 cases, right? See, in the case of convex mirror you are having the focus and center of curvature behind the mirror, means this both are virtual focus and virtual center of curvature. So in first case we will consider an image object at infinite. Okay, so let's say we are having an object, AB, okay, at infinity. So we need to consider parallel incident rays. So let's consider the parallel incident rays. okay, which is incident on the plane mirror. Here also you can consider it. Okay, let's say here. So these all are parallel incident rays from the object at infinite is incident on the plane mirror. Okay, so now after reflection, as convex mirror is diverging mirror, it will diverge the light rays. Okay, so it will diverge the light rays like this. It will diverge the light rays, and it is apparently passing through the principal focus. Okay, so this is the rule that we have seen for the convex mirror. Okay, it is apparently passing through the principal focus behind the mirror. So in this case it will also be like this. Okay, it is. Now you can see that this here it will reflect back on the same path as it is passing through the center of curvature. So you can see this, these all are diverging rays. Okay, so they are apparently meeting at some point behind the mirror. So here that point is focus, principal focus. Okay, so here the position of object is at infinite, or you can say infinity. Then position of image you are having behind the mirror, and where you are having the image that at f, the size of image is highly diminished. You can see highly diminished, or you can say point like. And nature, as we need to extend the rays, it will be virtual and erect in nature. Okay, now taking an object in front of the convex mirror. Okay, so let's say we are having an object somewhere over here. We are having an object somewhere over here, AB. So here the position of image will be like this. You can write anywhere. Okay, anywhere between infinite and pole. You can place it anywhere between the infinite and pole. So let's locate the position of image. So first of all, let's consider the light ray which is parallel to the principal axis. Okay, so it will reflect back like this. It will diverge the light ray like this, and apparently it is passing through the principal focus. Okay, now you need to consider the second light ray. You can consider it passing from focus and center of curvature or from pole. All three are valid. Let's consider the light ray which is passing through C, and see if it is passing, it is incident on if it is incident like this, apparently it is passing through C, then it will reflect back on the same path. If it is incident like this, it will reflect back on the same path. Now you can see this light ray and this one, both are diverging, so we need to extend them back. Okay, so when you will extend these two light rays, okay, the intersecting point is somewhere behind the mirror at this point. So at this point you will get an image. Okay, so at this point you will get an image. Here you are having an image. You can say A dash B dash. Now you can see that this image is smaller than this one. Okay, so the position of image is again behind the mirror and between pole and focus. Okay, between P and F, behind the mirror. The size of image, you can say it is diminished. Okay, diminished size you are having, and the virtual and erect nature will be there. Nature is virtual and erect. Okay, so this is the image formation for the convex mirror. So total 8 image formations are there, 6 for the concave mirror and 2 for the convex mirror. So here remember one key point. Here I am writing. Okay, see in convex mirror, in case of convex mirror, okay, you will always get diminished image. Okay, you will always get diminished image. You will always get virtual and erect image. Okay, you will always get virtual and erect image. Okay, and the position of image will be always vary between P and F. Okay, so it means that if object comes closer to mirror, if you are taking an object closer to mirror like this, then image will move from F to P. Then image shift from F to P and size increases. Okay, and vice versa you can also consider. So if you are moving an object towards the convex mirror, the size of image will get increased like this, okay, while moving from F to P. So if you are taking an object near to the mirror, the image will shifting towards the mirror like this, okay, and its size will gradually increase. It will be like this. Object is coming, it will point like initially. If you are taking object near, then it will increase like this. Okay, so this is the concept for the convex mirror. Okay, now let's see the uses of concave mirror and convex mirror. These both are very important 2 marks question. Okay, so let's see the first one, the uses of convex mirror. So convex mirror is commonly used in, you can say, torch, searchlights and headlights of the vehicle to get the powerful beam of light. It is just because concave mirrors, okay, these torches are placed at the focus of convex mirror. Okay, let's say we are having concave mirror. Okay, so let's say we are having a concave mirror like this. So at F they placed a light. So at F they will place a light. So the light rays will incident on the mirror like this. So it will reflect back as a parallel beam. So this is the concept of using the concave mirror in torches, searchlight, vehicles, headlight. Okay, then they are used for shaving mirrors. Okay, now you can see in the case of convex mirror, they are always giving the diminished image. Okay, and in the case of concave mirror, it used to give the enlarged image. So to see the enlarged image, it is used in the shaving mirrors. Same for the similar purpose, it is used by the dentist. Okay, to see the larger image of teeth of patients. Then large concave mirrors are used to concentrate the sunlight to produce heat on solar furnace. Okay, so on the same principle it is working. Okay, it is just reverse because the sun is at infinite distance, so parallel beam will incident on the surface, and here we will put some material to heat up, so it will converge the light rays to the principal focus and it will heat up the material. Okay, so these are the basic uses of the concave mirrors. Now let's see the uses of convex mirror. So see, the convex mirror are used commonly as a rear view wing mirrors in the vehicles. These mirrors are fitted on the side of vehicles, enabling the driver to see the traffic behind for safe driving. So the mirrors that you are having in your vehicles, that are usually the convex mirror. Why to use the convex mirror? This reason is very important. Please remember this reason. Okay, so first is they always give the erect image, that what we have written over here. It always gives the diminished image, that is also written. The second is it will have the wider field of view as they are curved outward. You can see the curvature. So as compared to the plane mirror, this is having a wider field of view due to its curvature. Thus the convex mirror enable the driver to view much larger area that would be possible with a plane mirror. So in fact, instead of plane mirror, we are using the convex mirror as a rear view mirror. And if someone asks you the reason in the exam, then you must write this point. Okay, so these are the uses of concave mirror and convex mirror. Okay, now you can see the difference between the concave mirror and convex mirror. Again, it is an important question. You can see it in your screen. Okay, the first point is, in the concave mirror we know that the inner side is reflecting surface, and in the case of convex mirror the outer side is the reflecting surface. Then in the second point you can see that focal length and you can say the principal focus and center of curvature, it both lies in the front of mirror. Okay, and in the case of convex mirror they both lie behind the mirror. In the third case, concave mirror are also called as converging mirror, that I said before, okay, in the previous lectures. Then convex mirror is known as the diverging mirror. Okay, in the fourth point you can see that concave mirror forms the image real and inverted image and virtual and erect image. So it depends on the position, at which position you are placing. That's what we have seen in this lecture, the image formations, right? In the case of convex mirror, you noted that it always forms the virtual and erect image. Okay, so concave mirror can form both real and inverted as well as virtual and erect image, but convex mirror forms only virtual and erect image. Okay, now magnification. Okay, so magnification is can be, the value of magnification can be less than 1, equal to 1, or greater than 1. So less than 1 is for the diminished image, equal to 1 is for the same image, and greater than 1 is for the magnified image. But in the case of convex mirror, it always forms the magnification less than 1, as we noted that it always forms the diminished image. Okay, and in the last point you can write the uses of concave mirror and convex mirror. You can mention the uses in that last point. Okay, so concave mirror is used in the headlights, while convex mirror is used as a rear view mirror. So that's it from this lecture. Okay, so please like, subscribe and share the channel if you are really finding it helpful. Enjoy the learning here. Okay, so keep working hard, keep learning. Thanks a lot.